Hello GCC students. Today we're going to talk about the 6 types of chemical reactions. They are sitting here on your screen right now. The first one is pretty easy. It's called combination. This is when we take 2 or maybe 3 small chemicals or elements and combine them together to form one big compound. So we're combining things together, thus combination. The second type of reaction is the opposite of that. We're going to start out with one big compound and it's going to break down or decompose into 2 or 3 smaller molecules or elements, and so it's called decomposition. So combination and decomposition are opposites of each other. The third chemical reaction is combustion. This is fire. So fire requires what to support a flame? You're correct if you said oxygen gas. So for combustion reactions, we're always adding something to oxygen gas. So the reactant side is something plus O2 gas. That something in Chem 130 is a hydrocarbon. That means a chemical made up of hydrogen and carbon. So CH compounds. So we take a CH compound, add some oxygen gas to it, and we can have a combustion reaction. The products are going to be gases that float away because fire is hot. These gases are carbon dioxide and water vapor. So carbon dioxide and steam, water vapor, same thing, are gases, both of them, and they float away. Now remember that it's not H2O liquid. No one ever said, I'm thirsty, light a fire so I can drink the water. No, no, no. When we have a combustion reaction, it's hot. So the water is hot, it is steam, it's a gas, it boils and floats away as a gas. So a combustion reaction is a hydrocarbon plus oxygen gas making carbon dioxide and water vapor. The fourth reaction is an acid-base reaction. We learned in chapter 9 that an acid is a chemical that usually has an H in front. And a base, for us, Arrhenius bases, are something that have an OH hydroxide in back. Now what happens when an acid and a base come together is the H in the acid and the OH from the base join up, hook up, and make HOH. What is HOH? Right, it's water, and this is liquid water. So it makes water. And then we have whatever's left over coming together. So we're going to have a non-metal from the acid and typically a metal from the base. So those come together. And when you have a metal and a non-metal, that's an ionic compound. So we're going to make an ionic compound, a metal with a non-metal. Now remember, if you're writing this reaction out, you have to check your charges of your metal and your non-metal to make sure they add up to 0. For example, sodium chloride, Na is a +1, Cl is a -1, +1, -1 adds up to 0. So 1 Na and 1 Cl come together. It's not always +1, -1 though, so check your charges. Next we have the replacement reaction. Single replacement is first. A single replacement reaction is when you have a single metal by itself. Single metal, single replacement. So we have a metal plus something. It is either an acid or an ionic compound with another metal. So for single replacement reactions, if we have a reaction, the metal needs to be more active than the metal in the compound. If it is, that metal will kick out the metal in the compound and replace it, joining with the non-metal X. So the metal will kick the A out, join with the X and make MX plus A is by itself. So we have a metal replacing something in a compound if it's more active than it. Single replacement, single metal. The last one is a double replacement reaction. And this is where we have a metal plus a non-metal and another metal plus a non-metal. And we're going to have a metal-metal switch. So double switch, double replacement. Metal 1 will go with Y and metal 2 will go with X. Again, anytime you have a metal and a non-metal coming together, you have to check your charges if you're having to write your own products. So for single and double replacements, you'll have to do this. Single replacement, you'll make one metal nonmetal compound, you'll have to check your charges. And for a double replacement, you'll actually have two metal nonmetal compounds, and you'll have to check the charges for both of them. So that's kind of an overview of your 6 types of chemical reactions. I hope that helps you out. Have a great day, GCC. Bye-bye.